Now let's start solving this self-assessment question. Under this question, the equation is giving us t squared plus 2ty multiplied by y prime equal to y squared. So that is the differential equation. And looking at this differential equation, you will notice that it is nonlinear, because if I should expand the bracket, y will multiply its derivative, and even here is raised to the power 2. Therefore, this is nonlinear, and the order is not also Bernoulli equation. So we have to look at a way of solving this. Now, before we solve this one, let's consider this equation. If you have something like this, y prime is equal to t squared over 1 minus y squared. Now, from this equation, you can see that I can easily cross multiply to get 1y squared equal to t squared. It means that all the y values are on the left hand side and all the t's are on the right hand side. Whenever you see such differential equation, it is called a separable differential equation. Once we are able to separate it like this, the next thing to do is to integrate this part with respect to y. Then we also integrate this with respect to t. Then we can do that and make y the subject, and that becomes the solution. Now let's go back to our question. Looking at our question, you will notice that trying to grouping all the y's on the left hand side and all the t's on the right hand side will be very difficult. It is not easy to do that. Therefore, we have to use what we call substitution. And whenever we are doing the substitution, we have to do the substitution in such a way that whatever we will substitute inside will be invariant. Invariant means it will not cause the equation to change. It will not cause the equation to change. Now let's assume you have something like t over q. If you substitute something like this into an equation, remember that if t is multiplied by some constant c and q is also multiplied by c, they will cancel out. Therefore, the whole thing will not change. So that is what we call invariant. So as we move on, we will understand that. Now let's start analyzing the question. The first thing we can do here is to divide through. Let's divide through by y squared. So I will divide here by y squared. Then I will also divide this by y squared. If I do that, I will get t squared over y squared plus y will cancel one of the y's, so I'll get 2t over y then all this multiplied by y prime should be equal to 1. So that's the first thing for us to do. Now when we get to this point, you will notice that t squared over y squared can be written as t over y all squared, then plus 2t over y, then all put in brackets multiplied by y prime. Now here is supposed to be 1, should be equal to 1, should be equal to 1. Now from here, we can see t over y here, we can see t over y here. So it will be better to let our u be equal to t over y. Let our u be equal to t over y. And if t is equal to u is equal to t over y, then we can make y the subject. So let's make y the subject from here. Y will be equal to y will be equal to t over u. So now we have y to be equal to t over u. Then what do we have to do? We have to differentiate y. We are going to differentiate y with respect to t. So we are differentiating with respect to t. Let's take note of that. So I'm going to apply the quotient rule. So using the quotient rule, my y prime will be equal to, you know that, so let me do it step by step. Start with the u, hold u, and differentiate t. You differentiate t with respect to t, you will get 1. So that is it, minus hold t and differentiate u. If you differentiate u with respect to t, you will get u prime. So you are going to get t multiplied by u prime. Then all divided by the denominator squared. The denominator squared. So that is our y prime. Now from here, we are going to substitute y prime and t over y into this. We are to substitute this into it. So what do? Let's take it step by step. I want to simplify everything here so that let us start with the simplification. You will notice that with my bracket, I have t over y, and we know that t over y is u. So let's put it there, u squared, then plus another 2 multiplied by t over y, so we will get 2u. So all into brackets, y prime, and we know y prime to be equal to u minus tu prime all over u squared squared should be equal to 1. But take note that we are not supposed to when you get to this point, we can do some cancellations. So let's try and cancel out. You can see that here is u squared. This u squared is multiplying through, so I can multiply through by u squared. I'll multiply here by u squared, then I'll multiply here by u squared. So if I do that, I'll get this u squared will cancel this will cancel this. So I'll get u squared plus 2u multiplied by u minus tu prime, then should be equal to u squared. So that is it. Now the next thing to do is to expand. So let us expand. When we expand this, we will get u cubed. U squared times u will be u cubed. Then u squared times this will give us u squared or tu squared minus tu squared multiplied by u prime. Then 2u times u will be 2u squared. Then 2u times this will give us negative 2t u, then u prime. This should be equal to u squared. This should be equal to u squared. So from here, you can see that u is common in all the terms, so we can reduce all by one exponent. So divide here by u squared. No, I'm dividing through by u. Divide here by u, or here by u. Then you also divide here by u. So here becomes u squared minus ut u prime plus you have 2u minus the u and the u goes away, so you have 2t u prime, then that will give us u. So that is it. Now let us continue to simplify. So I have u squared here, I have plus 2u here, and this u comes here to be minus u, should be equal to, then I have positive 2t u1 here, which gives me, when it crosses, it will become positive 2t u prime, and this will also be plus ut u prime. Now 2u minus u will be u, so I have u squared plus u should be equal to, this part will be 2t u prime let me write it 2t, or let me write it this way, 2t u prime. Then here becomes ut plus ut u prime. Alright, so I still have u squared. Sorry, let me go back and do something here. Now you can see that from here there is t here, there is t here, so we can just factorize it out. It will cancel out. There is t here, there is t here, so let's factorize that out. We will get 2u prime plus u prime, all multiplied by the t. Yeah, so we can do it this way. So when we do it this way, then it means that we are going to get think there is something wrong. Let me still go back and simplify this well. What we need to do here is to rather factorize u prime out. Let's rather factorize u prime out. Here we know here to be u squared plus u should be equal to, let's rather factorize u prime out. So I'll get 2t plus ut all multiplied by u prime. Now let's take note that this u prime is the same as du dt. So u prime is the same as du dt. So let us introduce that. We will get u squared plus u should be equal to 2t plus ut multiplied by du dt. Good. So from here, let's multiply both sides. I'll cross multiply. If I cross multiply, I'll get, so here the best thing to do is to reciprocate each side. If I reciprocate, I'll get 1 over u squared plus u. Then should be equal to, here becomes dt over 2t plus ut all multiplied by du, all multiplied by du. Then from here we can multiply through by 2t plus ut du. So if I do that, I'm going to get 2t plus ut all over u squared plus u should be equal to dt over du. So that is where we have gotten to. Let us continue. So from here, you can see that there is t here and t here. So I can factorize the t out. So I'll get 2 plus u. I'll get 2 plus u multiplied by t, all divided by u squared plus u. U squared plus u should be equal to dt du. Now I can still cross multiply. If I cross multiply, I will get 2 plus u over u squared plus u. All this multiplied by du should be equal to 1 over t multiplied by dt. Now let's look at this well. You will notice that this time all the u's are on the left hand side and all the t's are on the right hand side. So that is the first step. So this is now called separable differential equation. So we need to proceed and solve this one. So the next thing we need to do is to integrate. We integrate 2 plus u over u squared plus u with respect to u. Then we also do the same thing here. We integrate 1 over t dt. We integrate both sides. So we are going to take them one after the other. So now we have 2 plus the integral of 2 plus u over u squared plus u du should be equal to the integral of 1 over t dt. Now let's take them one by one. So we will solve the left hand side using partial functions or partial fractions. So let's focus on this one. We know that the integral of 2 plus u over u squared over u du. To solve this one, let's focus on the partial fraction. We know that 2 plus u over u squared plus u. This can be written as 2 plus u over u out. Then you have u plus 1. And this can be written as a over u plus b over u plus 1. And I believe that we can also solve a partial fraction like this. So I will not waste time. If you are able to solve it correctly, you will get your a to be 2 and you will get your b to be negative 1. Therefore, the whole partial fraction can be written as 2 over u minus 1 over u plus 1. So it means that integrating this is the same as integrating this with respect to u. With respect to u. Now we can take them one by one. This is going to be 2 integral of 1 over u du minus the integral of 1 over u plus 1 du. And if I integrate this, you will get 2 multiplied by the natural logarithm of u minus the natural logarithm of u plus 1. So that is the first part. So when we integrate this part, that's what we will get when we integrate. Now let us also look at the right hand side. Now with the right hand side, we have the integral of 1 over t with respect to t. And this one is very simple. When we integrate this one, we will get the natural logarithm, that's ln t plus an arbitrary constant c. So from here, we can now substitute everything back into this. So it means that we are going to get, substituting everything into it, you will get 2 ln u minus ln u plus 1 then should be equal to ln t plus c, ln t plus c. So that is it. We can apply the laws of logarithm here. Applying the laws of logarithm here, we can rewrite this one as the natural logarithm of u squared all divided by u plus 1 all squared should be equal to ln t plus c. Remember, using the exponent law, these two will come here to be squared. Then because it is division minus, you divide. So that is the laws of logarithm should be equal to this. So from here, we can take ye of both sides. If I do that, then the ye will cancel this. So I have u squared over u plus 1 all squared should be equal to, this becomes, the ye will affect this loss of indices, so we will get ye to the power c, ye to the power c multiplied by ye to the power ln t. Then we have u squared over u plus 1 all squared should be equal to, this whole thing can be written as some constant c. We can still use c or k. Let me use k. You can use c or whatever constant multiplied by ln t. So that is how far we have gotten to. Now from here, we can still do a lot. We know that this whole thing can be written as u squared over u plus 1 Or let me even write it straightforward. We can put them together. So we have u squared. Let me take it straightforward. U squared over u plus 1 all squared should be equal to, now u to the power ln t will give us t, so you will get kt or tk. So that is it. Then when we get to this point, we can square root both sides. When you square root both sides here, you are going to get u over u plus 1. So let's do that. When I square root both sides, I'm going to get u over u plus 1 should be equal to plus or minus the root of tk. Or let me put it this way. So that is correct. Then we have u over u plus 1. Remember that k is a constant, so it can be written as should be equal to plus or minus root of k multiplied by root of t. Then plus or minus root of k is also a constant, so we will get u over u plus 1 should be equal to u over u plus 1 should be equal to, when we get to this point, we can still introduce another constant, so which is c root t. So finally, this is where we are. So let us write that down. U over u plus 1. U over u plus 1 should be equal to c root of t. U over u plus 1 let me go back. U over u plus 1 is equal to c root of t. But remember that we made a substitution from the very beginning that u is equal to t over y. So u is equal to t over y. Let's take note of that. U is equal to t over y. So we can substitute that inside, then we will get t over y divided by t over y plus 1 should be equal to c root of t. Now, where we have gotten to, we can say that it is the solution implicitly. This is the solution implicitly. But the question is asking us to find an explicit solution. Explicit solution means we have to make y the subject. Y has to stand alone. So let's do that. We can do that by multiplying. Let's multiply the numerator by y and also multiply the denominator by y. If I do that, I'll get t over t plus y should be equal to c root of t. So now from here we have to make y the subject. So to make y the subject, the first thing I'll do is to reciprocate. So if I reciprocate here, I'll get t plus y over t. Then here becomes 1 over c root t. Then I'll multiply through by t. If I multiply through by t, I'll get t plus y should be equal to t over c root of t. Then t plus y should be equal to, now t over root t can be written as t multiplied by t exponent 1 over 2, exponent negative 1 over 2, and this one will give me t exponent 1 over 2, t exponent 1 over 2. So this whole thing can give me t exponent 1 over 2 up over c. Then I can make y the subject. Y is a function of t, which is equal to, this one can be written as root of t over c, then minus t, and this solution is explicit. That is by making y the subject. Now the question contains an initial value. We were given an initial value problem, which is y1 should be equal to 1. It means that wherever you see t, you put 1. So we are going to get 1 should be equal to root of 1 over c minus 1. And this will give me 1 should be equal to 1 over c minus 1. So I'm getting 2 should be equal to 1 over c. And I can see that c is equal to 1 over 2. So my arbitrary constant is 1 over 2. I can now substitute it here, and I will get y of t to be equal to root of t over 1 over 2 minus t. And I can simplify this to be y of t should be equal to 2 root of t minus t. And that is the final answer.